Hello, and welcome to Badger Talks Quick Picks, which bring exciting happenings, resources, and talent from your UW flagship campus to the people of Wisconsin and beyond. I'm Martha Barta from Madison, Wisconsin. I'm a recent graduate from UW-Madison with a major in conservation biology and Spanish. In the fall, I will be joining the Department of Ecology and Evolutionary Biology at Tulane University to study avian behavioral ecology. I am pleased to introduce Zach Feiner, who will speak on how the Great Lakes will respond to our changing winters. Climate change is rapidly altering the length, severity, and timing of Midwestern winters. Aquatic ecosystems, like the Great Lakes, are adapted to having long periods of ice and cold, meaning the loss of historical winter conditions can have substantial impacts on the entire lake ecosystems from plankton to fish. This talk explores how shorter, warmer winters are already influencing Great Lakes ecosystems, from reduced ice cover to increased algal blooms and changing habitat for important fish. Dr. Zach Feiner is a fisheries research scientist with the Wisconsin Department of Natural Resources and the University of Wisconsin-Madison Center for Limnology. His research focuses on inland freshwater ecosystems, including the impacts of climate change on freshwater fisheries, angler behavior, and the effects of fishing on ecological and evolutionary processes in fish populations, and the importance of changing phenology to the function of aquatic ecosystems. In addition to his research, Zach co-chairs the Wisconsin Initiative on Climate Change Impacts Fisheries Working Group, tasked with identifying and developing adaptation strategies for climate risks to Wisconsin fisheries. Please welcome Dr. Zach Feiner.
All right, thanks, Martha, for the introduction, and thanks for the invitation to come and record this talk about how climate change is going to influence our Great Lakes ecosystems. As Martha said, I'm going to be focusing my talk mainly today on how winters are changing in the Great Lakes and how that influences how those ecosystems function. So I always like to start a talk like this with this slide, and just to show how much our climate is changing here in the state. This is a really interesting app that anyone can go to, and you can punch in a location, and it'll actually give you a heat map to show what the projected climate of your region was going to feel like by 2080. And if you punch in central Wisconsin into this map, what you get is projections that by 2080, central Wisconsin is going to feel a lot more like central Illinois or even northern Missouri, which you can imagine is a very, very different climate from what we're experiencing now. And climate change is going to bring a lot of different impacts to our ecosystems. I think the first thing that a lot of folks think about when they think about climate change is warming, and we are projected to get warmer here in the state. But there are a number of other things that are going to occur. For example, we're projected to have more extreme events like storms or polar vortexes or heat waves, in addition to more precipitation that can lead to flooding and runoff of nutrients into our lakes. We're also expecting to see more novel conditions. So that can be things like intense algae blooms or lakes that are in rivers that become too warm for some of those species that currently live in them to be able to survive in them much longer. In addition, climate change is projected to change how our seasons act in the region. So for example, we experience one of the earliest ice-offs on record in the Great Lakes and lowest years of ice cover in the Great Lakes this past winter. And we're expected to see more and more of those types of seasonal changes to the timing of when the lakes freeze and thaw that can have major impacts to how these lakes function, which I'll talk about in a little bit. So overall, we're expecting to experience a new, less predictable environment due to the effects of climate change. And this talk is really going to focus on some of those changes. To kind of focus in on the Great Lakes, I think one of the things that, as I mentioned, a lot of people expect is that the lakes are warming up. But what I do want to point out is that the lakes are not warming up all at the same rate everywhere, right? So this is a map showing kind of the trend or the increase in temperature over time in Lake Michigan and Lake Superior. And what you can see right away is Superior is warming much faster than Lake Michigan. And what this means is that species that like cold water, for example, this little lake trout here, may have to move offshore to deeper, colder environments, or may have to change their distributions entirely and move north to find their cold environments in a warming lake system. In addition, Lake Superior is actually protected from a lot of the species invasions we felt in the Great Lakes because it currently gets too cold for those species to be able to thrive in Lake Superior. However, as Lake Superior warms up, it may become more susceptible to expansions of populations like zebra mussels or quagga mussels or around gobies. So you may see new ecosystems and new species moving in as these lakes warm up and the habitat changes. But warming is not the only impact on the Great Lakes. We're expected to see more intense runoff from these storm and rain events that can very dramatically alter nearshore habitats. This is a great image of a storm that's caused a giant plume of sediment to flow into Lake Superior, for example. As I mentioned in the previous slide, we're expecting changes in phenology, or the timing of seasonality of events, like the timing of fish spawning. So spring spawning fish may start spawning earlier, and fall spawning fish may start spawning later, which have big impacts on their ability of their offspring to survive. And in the Great Lakes, as in many other inland lakes, we're expected to experience more algae blooms, which can influence water quality and how much fun it is to swim in the lake, but can also influence things like the amount of oxygen that's available in the lake as well. So very big changes to these habitats with climate change. And finally, another dramatic impact of climate change on the Great Lakes ecosystems is that we're expected to experience much larger and more dramatic changes in lake level. So this is a great example from the WICCI Great Lakes Climate Change Report, showing how much the lakes can change in their level over time. So you can have changes in the lake level by tens or even hundreds of feet over time within a couple of decades, where they've gone from record low lake levels to record high lake levels. And again, imagine how much that has changed nearshore habitats in these systems. Now, where things get complicated is that all of these things are interacting with each other at the same time, right? Changes in temperature are influencing algae blooms, also influencing fish spawning and lake levels all at the same time. This plot is supposed to look a little complicated and scary because that's how we view climate change in the Great Lakes. All of these operations are acting at the same time and interacting with another. And rather than spending the rest of my time going piecemeal through each of these things, I want to try and tell one single story, which is the story of the loss of winter in the Great Lakes. And I'm going to tell this story through the viewpoint of two of our most important fish species to Great Lakes economies and the ecology of the Great Lakes, which are lake whitefish and yellow perch. And my hope here is that by focusing on these two species and the impacts the loss of winter on the Great Lakes has on these two species, it allows us to see how complex some of these interactions can be and how we need to think about this when we're managing Great Lakes ecosystems. So one of the things I want to point out right away is that winters in the Great Lakes are getting shorter, warmer, and more variable. And so if you look at, and we view this very often through the perspective of how much ice cover there is on the Great Lakes. So on this plot here, we can see this is the proportion of the lake that's covered by ice. And you see this is going down over time. But another thing that's occurring is you see how much more variable it's getting. These points are jumping up and down quite a bit more in recent years. And if you look at that variation, which is what this plot is showing, you can see that's increasing over time. So we're getting shorter and more unpredictable ice cover in general in the Great Lakes. And I think this is really nicely exemplified by a couple of years that happened about a decade apart. In 2014, we had some record high coverages of ice cover in the Great Lakes. And this is a great satellite image showing, for example, Lake Superior being almost totally covered, Green Bay totally frozen, lots of ice on the lakes there. In contrast, in 2024, this past winter, we had a record low ice cover. And what this means is there's virtually no ice on any of the lakes at all. And this is a really great contrast to see how much things have changed, even in the past decade or two. Why this is important is because lakes have ecological memory. And what this means is that the amount of ice that is covered in the lakes during the wintertime actually influences how they function the entire rest of the year. In a very low ice cover year, you get very little ice cover, and this earlier ice off allows the lakes to heat up a lot more before they stratify, and you end up with warmer water temperatures. In contrast, in a high ice cover year, you can have lots of ice cover. That ice doesn't melt until late in the year. Those lakes don't heat up very quickly in the springtime, and you get colder water temperatures for the rest of the year. So just by changing the amount of ice cover on the lakes, you can have very different changes in the kind of temperatures that these lakes have and the kind of habitats they can make available for different fish species. The reason this matters is that for fish, temperature is habitat. In the Great Lakes, there are lots of different fish species that have very different temperature preferences and temperature criteria that they need to carry out aspects of their life history. So, for example, a lot of our trout and salmon species and whitefish species are cold water fish. They like cold temperatures and need cold temperatures to carry out their life cycle. In contrast, perch and walleye and other species that can be cool water fish, and then there are also warm water species like bass and bluegill. And we expect warming waters to reduce habitat for cool water species and increase habitat for warm water species over time. Now, to focus in on these temperature effects, we can think about the impacts on lake whitefish, which is the first story I'm going to tell you today. Lake whitefish are an important Great Lakes commercial fishery. If you've eaten a fish boil in Door County, you've probably eaten lake whitefish, or you've maybe seen it on a menu at a fish fry here or there around the state. So they're very important ecologically and economically for a lot of Great Lakes areas. And the history of Great Lakes is one of very large whitefish fluctuations in abundance. They're actually at fairly low abundances in the 1970s. They used to support a very big commercial fishery, and then due to a number of ecological changes in the Great Lakes, they declined. But they actually experienced a kind of a renaissance in the late 1990s after declining again. This is the whitefish catch in Lake Huron and Lake Michigan is what this plot is showing, in addition to the other Great Lakes. And the question becomes, well, why are they declining now in the 2000s? And one possible culprit is climate change. So what this slide is going to be about is how climate change is going to influence lake whitefish reproduction and their habitat availability throughout the year. Whitefish are an interesting species because they actually spawn in the fall. They'll move into very shallow areas, lay eggs in these rocky areas in November, and then the ice freezes over these eggs. It actually stabilizes these environments, and those eggs will overwinter all winter long and then hatch in the springtime. And they have in cold winters and warm winters can have very different impacts on the egg survival. For example, in a very cold winter, you have ice cover. It stabilizes those environments for those eggs, and those eggs can develop and hatch in the springtime in a fairly stable environment. In contrast, in a warm winter, with no ice cover, you can get wind and waves and storm events that are actually dislodging these eggs or covering them up with sediment so that they suffocate and don't survive. So in a warm winter versus a cold winter, you can have very different egg survival, where you have high egg survival in a cold winter or low egg survival in a warm winter. In contrast, we can actually see the opposite effects in the springtime. Eggs hatch into little baby whitefish called larvae. And in the cold winter, the growth of those larvae may be suppressed, and the production of their food, the zooplankton, may also be suppressed because those are dependent on temperature. In contrast, in a warm winter, you may have more zooplankton production and faster larval whitefish growth. So there you could actually have higher survival of these whitefish larvae. So right away, you see, based on the differences in the life history and the life cycles of these fish, you can have different impacts of climate change. And those impacts are not limited to those offspring. Adult whitefish are also going to be responding to climate change very dynamically. In a cold winter, nearshore habitats may stay cold longer, and those whitefish can use those nearshore habitats for a longer period of time. In a very warm winter, those nearshore habitats may warm up too fast, and whitefish actually have to move offshore to find optimal thermal habitat. So you can see big changes in the distribution of adult whitefish as well as the survival of their offspring based on these changes in cold and warm winters. What this means is that climate impacts on whitefish can be highly context dependent. Some regions may get better and some regions may get worse based on contexts like habitat or the pace at which the winters are changing. And this is something that Abby Lynch and some other co-authors looked at a few years ago, where they looked at projected changes in whitefish recruitment over time. And they found a mixed bag where some places are increasing, which is these green arrows, and some places are decreasing by quite a bit, which are these red arrows. And where this gets complex is that now this has to feed directly into how we think about managing whitefish. Again, they're a very important commercial fishery in the region. And if you're seeing different places increase or decrease with climate change effects, that may then change how you need to set quotas in some of those regions. And we need to think more constructively about how climate change may be altering the abundance and distribution of whitefish in the future. Now, I think whitefish offer a really great view into the complexities of climate change impacts. And now I'm going to talk about another species, yellow perch, that's spawned in the springtime, that are also suffering some impacts with the loss of winter. So yellow perch are a really interesting story because they've experienced a major collapse in Lake Michigan in the late 1990s. In the DNR in Wisconsin, they used to go out in Lake Michigan and do these gillnet surveys every year. And in the late 1990s, just kind of draw your eye to this table, they normally catching 14,000, thousands to tens of thousands of yellow perch in these surveys. And by the mid 2010s, they're catching single digits of perch. So a really dramatic collapse of these populations has occurred. And one of the questions then is, has climate change played a role, and how might climate change be influencing the ability of these populations to reproduce and sustain themselves? Well, one of the ways is because of how yellow perch and a fish in the same family, walleye, that I bet a lot of people have heard about and probably eaten as well, is how yellow perch reproduction works. So this is actually something I worked on during grad school. But the idea here is that yellow perch and walleye are actually allocating energy. They're moving energy into their eggs during the wintertime. And this is what this plot is showing, where they're going from having very little energy reserves in their eggs to having 20 to 30% of their body weight put into eggs. So if you're a human and manage carrying around like a 25 or 30-pound baby, right? That's how much energy they're putting into eggs. And it's all this is happening during the wintertime. So in the course of one winter, they're going from the skinny little perch to this big, ready to spawn female. And the question then is, how does winter conditions influence this process and the quality of eggs that these perch are producing? So we did some work on this a couple of years ago, and I'm not going to go into the details for time, but what we found is that when we held perch at different winter temperatures, in cold winters, yellow perch actually produce higher quality eggs. They had more fats and oils that really were able to provision those larvae that hatch out of those eggs to survive really well. And to kind of back this up on an ecological scale, at the same time as the study was performed on Lake Erie, which found that if we look across gradients of winter ice cover, so from very little ice to lots of ice, we only ever found lots of juvenile yellow perch, which is what this on the y-axis here, when in years where there are lots of ice cover. So you needed about 70% of the lake to be covered in ice to be able for these yellow perch to pull off a big year class. In other words, have lots of juvenile yellow perch around in the system. So this is really suggestive of the importance of winter ice cover. Having these long, cold winters helps the perch physiology get ready to spawn, produce high-quality eggs, and produce these good year classes. So with that, I want to conclude on a few different notes. I mean, the first is that I think I've shown that the Great Lakes ecosystems are changing and changing rapidly. They're warming up, the winters are getting shorter, and that can have very big impacts on how these lakes function the rest of the year. As I mentioned, in lower versus high ice cover years, you can have very different temperature habitats, very different phytoplankton and zooplankton production, and that can influence the entire food web of the Great Lakes. But these effects can be complex and context dependent, depending on the life cycle of the fish, the habitat those fish are looking for, and different habitats around the region, which mean we need to think very carefully about how we manage these fish species because their responses may not be the same from one place to the other. But the big takeaway I want to point out is that species are adapted to Great Lakes winters. They're adapted to live in a place where it gets cold and icy for several months out of the year. And when those don't happen, these fish cannot complete certain aspects of their life cycle and may struggle to persist in some areas of the Great Lakes. So I always want to point out that, I'm a fisheries ecologist and I talked a lot about fish today, but there are lots of other impacts of changing winters on Great Lakes ecosystems, right? Social impacts like fishing, tourism, transportation, ecological impacts like the legacy effects of changing ice on the frequency and severity of algae blooms, for example. We need to be continuing to think about these things as we think about managing the Great Lakes going forward. And hopefully we consider some proactive strategies to develop plans for how to manage these changing Great Lakes ecosystems. So with that, I want to again thank Martha for the great introduction and thank Badger Talks for giving me the opportunity to give this presentation. I also want to shout out the WICCI, the Wisconsin Initiative on Climate Change Impacts Fisheries and Great Lakes Working Groups. That QR code will take you to the website where you can look at our reports. A lot of the information I talked about today is in those reports. And I also want to mention all the different agencies and funding sources that supported some of the information in this talk, as well as my work. And I invite you to reach out via email or check out my website if you'd like to learn more. And with that, I thank you very much for your attention. Thanks.